All right, so as I was saying, some of this you guys already know how to do. Because when we talk about measures of central tendency, they're talking about what's the mean of the data, the median of the data, and the mode of the data. Those are three things that anytime that you're maybe looking at a data set, those would be helpful information to know about it because it kind of gives you a really quick snapshot about what's happening with the numbers. Because it's one thing to look at a bunch of numbers and maybe like I might look at your guys' test scores, for example, or like your quiz scores, and I can see individual scores and like I know what that means as far as how well you did. But if someone else randomly looks at that, it may not mean a whole lot to them because it's just a bunch of numbers. But if I could give them information like, well, my average quiz score was a 93%, that means something more to somebody else because then you're kind of understanding, okay, the majority of the class scored around there. Or if you talk about like your median or your mode, it just gives a little bit more context to what's happening in the problem. So I'm just going to go over what these are again for you guys. Like I said, some of this you probably already know or you've done before in the past, but we're going to just refresh our memories here. So mean has a symbol. Okay, so it looks something like that. It's a Greek letter. Okay, but that might be used when they're talking about the mean. And the mean is the average. So you guys could find the average of in your own life. Like if you had a bunch of tests that you took for a class, you could figure out what your average test score was. Or if you play a sport and you wanted to know like your average points per game or something like that, you could figure those things out by looking at your specific data from each game to game to game. Okay, median is the middle value. And I'll just put maybe in parentheses after this, I'm going to say data needs to be arranged. So sometimes when we look at data, it may not be put in order from like least to greatest for you. When you're finding the median, you need to do that first. You don't want to just look at the numbers that they give you and just find the one that's in the middle of the data. You have to put it in order first. So line them up. What's the smallest data point to the biggest data point, and then look for the middle. Mode or modes, because sometimes there might be more than one. This would be the most repeated value. So if a data point shows up more than once, that would be your mode. Or if it shows up 3 times or 4 times, or if you have a couple of data points that both show up 2 times, then they would both be considered the mode. Okay, so what we're going to do first is we're going to find these 3 things given a data set. So down below in this first couple of examples here, it wants you to find the mean, the median, and either the mode or modes for each data set. So they're giving you a lot of numbers. Again, we don't really have any context what they're for, but it's not what we really need right now. We just need to find these 3 things. So anytime that I start a problem like this, I always put it in order first because it's going to be more helpful to me when it comes to the median. So I'm just going to do that really quick. I'm going to look through and I go smallest to biggest. So the smallest number I see is 35. So I'm going to write that down. And then I like to cross them off as I go because it helps me keep track of what I've put down and what I'm still needing to work with. So then the next one would be 46. Then I think that's it for 40s. So now I'm looking at my 50s and I see 2 51s. Then a 53. I see 2 58s. A 59 and a 60. Okay, now to find the mean, to find the average, we're going to add up all of the data points here, and then you're going to divide by the total number. So I would just grab a calculator, and we're going to add up 35, 46, 51, 51, and so on. You're going to add all of those up together, and we're going to divide by the total number. There should be 9 values here total. So when you get all of the sum, you're going to divide that number by 9. So when I added them up on my own time, I got 471. Did anyone else get that?
Yeah.
Okay. And so to find the mean, I'm going to divide that by 9 because there's 9 numbers that they gave me. Now, we'll probably have to round this because you're maybe going to get a decimal here, and that's okay. What does your decimal come out to be?
52.3 repeating.
Okay, so over here where it says mean, I'm going to write that 52.3 repeating. Okay, I'm going to skip over the median for a second. Let's look for mode or modes. Are there numbers that are repeated? Okay, so 51 and 58 are both repeated twice, so they both are the modes. If they had maybe given us an extra 51 or an extra 58, then that would be the only mode, but since they're shared, they both get that title. Okay, now for a median, you're finding the middle of the data. Since there's 9 values, the middle should just be right in the smack dab center. So you can just kind of count 1, 2, 3, 4 on either side of it. The other thing that you could do, especially if you're dealing with a lot of numbers, is you could slowly just start crossing them off one at a time from the beginning and from the end. And whatever you're left with in the middle is going to be your median. So in this case, it's going to be 53. Now, let's say we had an even number of data points. So let's say we had 10 numbers. And so when I got down to the middle, it was stuck between 2. Do you guys know how to handle that situation? Like, I'm just going to throw this in here. Let's say they had a number like 54 in here. Okay, that would up my number of data to 10 instead of 9. If you don't have like a true middle, you have to find the average of these two values. So you're basically finding the middle of the middle. So what number would be right in between 53 and 54?
53 and a half.
53 and a half. Now, some of you might be able to think about that just mentally, but if you're dealing with numbers that are bigger, you would add them and divide by 2 because you're still just finding the average of the middle points there. But that only has to happen when you have an even number of data points. Odds, it should just be the one number that's in the middle. Okay? So I want you guys to go down to number 2 and do that one by yourself. I'll give you a couple minutes to work on that. Okay, what did you guys, when you added it all up, what did you guys get for your sum? Good, 228. And then how many data points did they give us? 12. So what is 228 divided by 12? 19. So that one came out to be nice and even and clean. All right, let's get down to the modes. Was there one mode or more than one? Just one. And what number is it?
24.
Good, 24, because that one shows up 3 times. Okay, now this time when you found the median, the middle, it should have been stuck between 19 and 21. Because again, we have an even number of points here. So what's the middle of the middle?
20.
20. Okay, and again, the other option is to add 19 plus 21 and divide it by 2, and you're still going to get 20. But they're close enough together that maybe you can realize that that number would be stuck in the middle. All right, questions on mean, median, and mode? Okay, so we're going to kind of take this a step further now. So we've talked about how to find like those 3 data points, and that's good because it gives us an idea of what the numbers are showing us and what they mean. But there's more that we can do with those numbers. There's more like getting into the real detailed part of it that we can start looking at that really allow us to understand what the data is showing. So this next thing I want to talk about is something called measures of variation. Measures of variation would be or could be a value that describes how spread out a set of data is. Another word for this would be measures of dispersion. So what this means is when you guys are given data, it can look one way when you look at the numbers, but then when you really start to look at some of these value points that we've been talking about, things can seem a little bit more different or maybe even possibly deceiving based on what they gave us. Something about when you're working with like data and like statistics and that, it can be used for a lot of things. I mean, think about when you guys watch TV. You hear commercials for like medications that are being put out in the market, and they talk about this percentage of people saw an improvement or like weight loss things and stuff like that. But if you really start to maybe dive into some of those things, I'm not saying that they're all lying to you, okay? But some of them, when you really look into like the detailedness behind their data, it might be a little skewed. Or maybe they're only sharing what sounds good and what makes them look good. And so data is helpful, but it can also be easily deceiving because we don't maybe always focus on what's really going on at the surface level of things. And so when we get into this next kind of portion here, this is going to allow you guys to really get into the details of data and understand how true or maybe how deceiving are these numbers with what they're asking me about. So the first thing we're going to talk about is something called the mean absolute deviation. And what this is, it's the average distance of each value to the mean. We abbreviate that MAD or MAD for short. And over here on the right, there's like a written out formula for how we would do this. But I'm going to show you how I would approach doing this if I wanted to find the MAD. But when you look at this symbolically, this X with the little I next to it, that's talking about data points, like a specific one in your list. Remember this symbol that we talked about, that Greek letter, that means the mean. So you're taking your data point and you're subtracting it. Now they do have it in absolute value because we don't want to have negative numbers here. We don't want to be working with negatives when we're talking about data. So no matter if you take like a data value and you subtract your number and you get a negative or a positive, the end result is always going to be positive. And then we divide it by the number of data points that we have. So again, we're still finding average, but we're just maybe getting a little bit more into the details here. So let's take an example on how to do this. So I've got a new data set here, 85, 74, 88, 80, 92, and 60. I want to find the MAD. The first thing I need to do is find the mean. I need to know what the average is. And we just learned how to do that. Okay, so to find your mean, we're going to add up all those numbers and we're going to divide by the total amount. So we have 1, 2, 3, 4, 5, 6 data points. Can you guys, someone add those up and tell me what you get?
79.83 repeating.
So that's the answer, right?
Yep.
Does anyone have what the total was when you added them?
479.
Okay. All right, so our mean here is the 79.83 repeating. We'll probably just use 83 for right now. And so now to find my MAD, I'm going to start taking these data points up here, and I'm going to subtract the average from them, okay? So for that first one, we're going to take 85, and we're going to subtract 79.83. You get 5.17, okay? So let's write that down. Then we're going to do it with the 74. So we're going to take 74 minus 79.83. Now you're going to get a negative, but remember I said this is technically an absolute value, so you're going to just take the positive side. So I got negative 5.83, but I just want you to write down 5.83. Okay, what should I do to find the next number? From 88. So I get 8.17. And we keep going. Okay, so we're going to do this for all of them. So 80 minus 79.83 is 0.17. Then 92, and we subtract it, we get 12.17. And then 60, subtract it, is negative, but change it to positive, 19.83. Okay, so all you did there is you took all your data points and you subtracted your mean. So we're adding those up because we're still finding an average, and then we're going to divide again by 6 because that's my total number of data points. So I got, when I added them all up, I got 51.34. And then we divide that by 6. And that comes out to be 8.556 repeating. Again, if you just want to round it to 8.56, that's fine. Or even if you just say 8.6, that's okay. You can round some of these decimals because they're going to start to get out of hand here pretty quick. Okay, but what this number means is that on average, my data point is about 8.6 spaces away from the true average. So again, why would we want this information? Well, if I'm looking at your guys' quiz scores and maybe my average shows that it's a 94% and like, wow, that sounds really good. Like all my kids got A's. You know, my class is awesome. They're so smart. But if I really start to look at it, well, yeah, maybe the average came out to that, but there could be some kids who scored significantly higher than that, or there could be some kids that scored lower than the average too, and it's kind of balancing it out because of that average mean. Okay, so I want you guys to try one. Go ahead and do number 4. I'll give you a couple minutes to do that because it is a little bit more of a process here. What'd you guys get for your MAD? 2.6? That's what I have. And I just kind of showed off to the right there what your work would have been. This time the mean came out to be a really nice number, so like finding the distance away from the mean should have been more whole numbers there. But yeah, your MAD should still come out to be about 2.6. Questions on finding that? It's not hard work, it's just tedious work. Like it's a lot of subtracting and adding and dividing. Okay, let's flip our page over here. Okay, so the last couple things I want to talk about is something called variance and then standard deviation. What variance is, and again, we're using another Greek letter here. Okay, so you see like this little tiny, looks like a little O with a tail hanging off of it. Okay, that's another Greek letter that they're using. In stats, you're going to see a ton of Greek letters showing up. But variance is the average squared distance of each value to the mean. And then we also have something called standard deviation, which looks very similar to variance. It's just instead of that symbol being squared, it's now just the Greek letter by itself. So it got rid of the squared. And so actually to find standard deviation, you just need to square root the variance. So it's the square root of the variance. Okay, well, let's talk about what do these numbers mean? Like, why would we need to know variance? Why would we want to know like standard deviation, that kind of stuff? So when you're dealing with your data, there could be a lower standard deviation and there could be a higher one. Okay, the lower standard deviation indicates that the values are closer together. And a higher standard deviation means that the values are more spread out. Why this is so important is because this allows us to see if data is truly showing us what we think it is or if it's being deceiving. A lot of times when you have a bunch of numbers, there might be something that gets snuck in there, like an outlier, or there might be a lot of numbers that are starting to really slowly, gradually spread away from the mean, and then it starts to make the data look a little bit more deceiving. If our numbers are closer together, that's a better representation of what's going on because it's showing a more unified front when you're talking about statistics. Okay? And again, a lot of this stuff, it's not hard work, it's just tedious work. And if you were in a stats class, like some of you might take stats next year, or even when you go to college, you might take a stats class, they're going to get a lot more into this information and like, why is it important? Why are people using this stuff? Okay, so like you may not use it from your day-to-day life. Like I don't use it a lot when I'm talking about grades and that, but people who are doing studies on the effects of things, they're really looking at the data like this because it's important to them because they're then pushing that information out to people like you and me wanting us to buy their products. And it's important that they're being transparent with what they found. So let's do an example where we find variance and standard deviation. Okay. The first thing that we need is we need to know what the mean is. Okay. So I need to find the mean first, just like what we've been doing. So with these numbers here, let's add them up. 85 plus 88, 91, 96, and 100. So I got 460. And then there's 5 numbers, so I'm going to divide by 5. So my mean is 92. Okay. To find your variance. So to find this, we're going to do kind of what we saw before. We were subtracting our data values. We're subtracting them from the mean, like what we were doing with our MAD. but this time you're squaring all of those numbers. Okay, so I'm going to write it out, but you're going to be taking the data value like 85 and you're subtracting the mean, 92. But then instead of just leaving it here, guys, you're going to square it. And you're going to do that with all of them. So 88 minus 92, and you're going to square it. 91 minus 92, and you're going to square it. And we keep going. And then, because we are still talking about an average, we're going to divide by 5. Again, this is not hard math. It's just a lot of calculator work. It's a lot of typing things in and just being really careful as you're typing in, because if you kind of skip a button or something, it's really easy to make a mistake. So it's not a time to go fast. You want to really pay attention to details here. Okay, so if you do that, you do all that subtraction, you do all the squaring, and you divide by 5, you should get 29.2. Okay, and if you didn't get there, you need to go back and maybe check how you typed it in, because maybe you missed a number. It's really easy to do that. Okay, but then the next thing to find just your standard deviation is you square root that number. So you just square root 29.2. And you should get 5.4. All right. The bottom of this page here, we are not going to go through because the calculators that you have do not have all the buttons to type all this stuff in. Okay, so we're just going to skip over that for now.